Welcome back, everyone. We're here for apparently episode 4. Uh,
Alternative fact.
yeah. I believe this week we're going to cover getting flakes built for specific projects and languages, and getting dev shells, configured for them.
Yeah, so I think it's good to do a quick little recap, which I can take care of just kind of like where we started and where we are, because remember, Nix is a lot of different components, right? And we've kind of touched a lot of different stuff. So again, like I said, at the core, like the core center of Nix, you have its language, right? And the language, as you can kind of see now, from how we've used Flakes to how you've kind of modified files on the system, you can see that it's just an integral part of how you configure and maintain Nix, right? Most of what you're going to do is going to be in a Nix file. And so if you have to ask yourself the question like, oh, am I doing something wrong, or like, how could I do this? I think the first way to, or at least start thinking about it, is like, how could I do this with Nix? And the more and more you use Nix, the more and more you're going to start asking yourself that question. Speaking of which, like, for example, Nix can do a lot of different things. Nix can build binaries for you. It can build shells for you, as you saw. And it can even, build entire operating systems if you want as well. So you kind of also want to be deliberate with what you want to build with Nix and try and optimize that approach. When we started, we set you guys up with Nix packages, but then we were like, okay, well, what we'd actually rather you use is Home Manager, because Home Manager does a better approach of managing the user space than like Nix itself, right? And then we took that even a step further, and we said, like, okay, Home Manager is really great and all, but like, it'd be nice to have a portable configuration, something that we can move around. And so that's when Flakes become a component and aspect to that too, right? All powered by the language and all, things that you use with the CLI tool. But I think getting comfortable with even just the terms and the things that we've talked about over the past 4 weeks is, I think, a really important way of getting comfortable with Nix, and so, yeah, like, again, we set up Nix on your guys' systems. We worked on setting you guys up with Flakes that had Home Manager built into it for configuration. And we've talked a bit about, the other possibilities and other things you can do with it, as well as like editors and stuff like that. So now, right, we're kind of at the point where we've really done as much as we can in the user space, right? Like, there's really not much else to do. Like, if you want more programs, you add it in Home Manager, right?
Yep.
If you want to modify Nix itself, you just go into the nix.conf and change that, right? And so, you have to then kind of ask yourself, all right, well, what's the next problem I want to solve? And that's really, I think, around development and development of applications, right? And it really kind of comes down to, like, how does Nix fit in the developer workflow? And what problems does it solve in that developer workflow, right? So to ask a quick question to both of you, what would you say in, like, as quick as you can possibly describe, what is your, like, most common developer stack? Like, what are the tools you're using, in the sense of, like, are you running Docker? Are you running binaries directly? Like, do you have watch files? Like, what does that process kind of look like for you guys?
So my two kind of stacks that I work in really commonly is the OCaml ecosystem, where we have things like OPAM and Dune as our main tools, and then the TypeScript ecosystem, kind of full stack, where obviously Bun, Node.
There's really only one choice in the TypeScript ecosystem for most things. It's not like you have 10 different choices.
Yeah,
or anything.
Very
like that, right?
cut and clear on the tools we should be using at any given time.
And so one of the things that you're going to notice with Nix and the problems that it can solve locally are, there are things that it can do that it will just remove certain components from what you're used to. And you kind of have to be comfortable with that. Like, for example, I think a lot of people are very comfortable with using like NVM for node version manager, right? To manage their node versions and stuff, right? With Nix, you don't need it. You literally just don't need it. There's no need for it at all. And like, here's an even step further. With Nix, technically, you don't even need npm as a package manager. Like there's no npm install technically required with Nix if you build and do everything through the Nix build system. Now, if you don't, right, then you have to depend on that. But yeah, and so that's kind of where you kind of have to, start looking around and investigating a little bit of like, okay, well, if you try and tackle it two ways, I think the first way you could do it is you could try and be like, all right, let me just, try and be as language agnostic as possible, right? I don't think that's a good approach, right? I think what's a better approach is like, I think people try and go like, let me make it as generalized as possible. And I think what's better is just to be like, make it specific to your exact project, right? Yep. And so I guess what I mean by that is like the moment this person goes into the project, what are the dependencies that person needs that you use? And, when you really start thinking about it and start putting it into Nix, you really start seeing like all of these different components come together in one place and Nix kind of running all of those things for you. I do think that it helps to pick a language that you're comfortable with, right? One that you feel like you have a good understanding of how everything works. Like if you don't understand how Rust builds, then maybe don't try packaging a Rust file as your first one, But, if you do have a good understanding of a specific language, I would say give it a try. And so that would be where I would start next, is I would say like, okay, like I know I want to work with a language, or I know I want to like build a project. What can that project be that I can start with? And so if you want, we can do OCaml. We can do any language, really. It's up to you guys. We can do, whatever you guys want. So I think what would be good is to pick a language, and then both of you will set up for the language of your choice. And I would say pick a language genuinely that you work in a lot and that you're comfortable with. Like, don't feel worried about, time or anything like that. Like, we'll be okay. So, okay. So I'm going to treat this like a magic trick. I know nothing about this repo at all. I'm basically fresh to it. I have no predetermined knowledge about it, right? So if I were to start, right, I would probably ask myself the first thing, which would be where are the entry points to the application, or where are the project related configurations for it, so that I could get an understanding of like what language it is, or at least like where, again, the entry point is for building, things like that, right?
Yeah, so kind of like how you see here, we have both a package.json file, classic npm thing, and then we have our Dune project file. So
now would you... Sorry, go ahead.
There is one kind of... This is a not standard OCaml project. We're using Melange in this project. So all of the OCaml code in this project actually ends up compiling to JavaScript. So we kind of have two build steps. We compile all of the OCaml with Melange, and then we bundle with Vite after that.
So do you only need Vite, or do you actually need a Node.js project structure?
We only need Vite. Well, actually, hold on. Give me a second to look at the actual repo here, make sure I'm not lying to myself. Yeah, actually, we don't need Vite at all. In fact, I don't even think we need... we probably need like Bun or Node to run. Probably Bun. I think that's what I want to recommend for people working on the JavaScript variant of this.
Okay. So we have the consensus that this is a OCaml project and a Node.js project, right? So we just need Node, essentially, and Node packages and things like that, right?
We'll need like the OCaml stuff too, like Dune and OPAM.
Well, yeah, I'm
maybe
saying
not OPAM.
Outside of the OCaml stuff.
Yeah, probably just Bun or Node, one of them.
Okay.
Doesn't
Hey,
matter.
Standard, how's it going? Let's. We have two problems that we have to solve. We have to solve the OCaml side, and then we have to solve the node side, right? So what I would say is let's do the OCaml side first, because the node side does actually get a little bit more tricky. What I would suggest is we're going to create a flake, right? The goal here is we want this flake to be the source of truth for the developer environment, right? This flake should have everything so that when somebody clones this repo, right, and executes or hops in this flake and they have direnv, right, they should get everything, right? And going back to the concept of like using Home Manager to configure things, this is really where flakes become really powerful, because you'll notice that it's not really that you needed, this binary everywhere on your system. It's just you had it in a lot of projects.
Yep.
And you just happen to use it in a lot of but you don't use it anywhere else, And so, like, for example, that's me and Just. Like, I use Just, which is like a make equivalent, essentially. I use that in pretty much all of my projects, but I had it installed to my home system packages or whatever, because it was just easier to have it there. But then I ended up removing that because it just eventually ended up in all of my flakes. Right. So we're not just trying to solve for the building of the software, but we are also trying to solve for that entire environment as well. The next part is a little bit of a point of contention for a lot of Nix users, like so many things. If you wanted, right, you could just make a bare bones simple flake. You wouldn't need to write any, or you wouldn't need to use any external packages or anything. Like, you don't need any packages to make a flake. You can pretty much do it all with the core schema that exists for it. However, there are nice libraries, just like there are with other languages out there, that make this a lot easier to do. And two of them that exist are flake parts and flake utils. Now, which one you use is kind of up to you. The biggest takeaway between these is that they are they're helpers to make it so that you can make flakes easier, and you don't have to rewrite a lot of the bootstrap code that is required to like passing packages and like selecting the system and all of that stuff. These will kind of help you by making it into like either a for loop or injecting the variable at a different level. And you will get people who will come in, and if they see you using one or the other, they'll be like, why aren't you using this one? It's like, this works. And it does. Like, it really does. But it's totally up to you. You can even, again, if you don't want to, you don't have to write any kind of, use any kind of flake at all or anything like that. But for now, we're gonna use flake parts. I just happen to like flake parts better because if you scroll down a little bit more, you'll see that they kind of provide you a base schema out of the box that you can use. And so what's nice is it's a really nice standardized interface that you end up just using in all of your projects. And you can immediately know, like, all right, what systems does it support, right? What are the flake outputs? There's a bunch of other features with it. But this kind of emulates the same concept that we do with, like, Make Darwin, right? Where this actually constructs a flake and then returns it based off of the additional parameters that you provide it. And one of the nice features there is the per system section. That is essentially passed down through parameters through the make flake function, so that when you want to define packages, you can actually just put them in that attribute set, and then you have the current packages already set. It will be passed in through that parameters after per system. So you can actually use packages, and I'll show you that more in a second here. One of the nice things about Nix, and we've kind of touched on this a little bit, is that Nix has the ability to do templating. right?
Right.
So as with kickstart.nix, you can use other repos as well to basically use their template to get started with. So when I first started making a lot of my own stuff and I hadn't gotten into using kickstart.nix, I was using this one a lot. This was kind of like my comfort to like, okay, I don't know how to make a flake. I'll just run this and I'll start with this. And like this for me is like my create Nix, right? You can kind
The
of think
Nix
of it as
flake
that.
and
Like
a
this,
dash T flake
Mhm.
parts, basically, right?
Pretty much,
Okay.
yeah. And so this will give us a basic flake to start with.
And I'm guessing I'm going to just do it right in the project directory here. All right. Now we have a flake.nix.
Cool. So this is the template that you get by running the flake parts, command. Now,
Mm-hmm.
if you use Kickstart, in all honesty, you're going to get flake parts, but the opinionation of the language that you're trying to build, we use flake parts as well because it's nice. It makes things a lot easier to configure and set up. And so most of the flakes use flake parts. Not all of them do, but most of them do. So to kind of describe what's going on here, remember that flakes have at their core inputs and outputs, right?
Yeah.
So at the top, you have inputs, and at the bottom, you have outputs. What's happening is flake parts really just wraps the entire attribute set that you return as your outputs in a function, and then that will return your actual flake settings and outputs. And that's where the flake parts lib make flake comes into play. And so what's happening is on line 7 above you, where the outputs is declared, it's saying, hey, right, inputs is my first parameter, right? And then after that parameter, evaluate make flake, and then make flake will take in inputs. It needs to inherit all of your inputs. So the @ sign you could kind of think of as like a spread destructor. It's basically what you're doing is you're saying, okay, I need to use the root inputs, but then I need to get values outside of inputs as well.
Oh,
And so
okay, I see.
you basically do both with that so that you can reference both a little bit more efficiently. It's just like syntactical sugar, basically.
Gotcha.
Yeah. So then we have a bunch of like options. Now we don't have to go back to the other page, but if you do want to see more of the available options that they provide,
Okay.
you can look at the flake.parts page, and they have a bunch of like flake outputs and settings and stuff like that. It's pretty nice. Yep. This is where you can essentially find all of the available like settings, integrations. It looks like, for example, it does have some Haskell Flake integrations, devenv integrations, dev shell, right? Things like that. OCaml's in there as well. But these
That's
are like
unfortunate.
these are like modules that kind of supports that you could work with if you wanted to, for example. Yeah, so this is like
interesting.
exactly, yeah.
So if we liked the way that they worked with OCaml here, you could use this template when you're building your own little OCaml flake and go from there.
Every time. Yep.
Mhm.
So if you click on the flakes parts built in the sidebar, you'll see it at the top.
Yeah.
Yep. This is the actual settings for the make flake attribute set that you're returning. So this is where you could say like, okay, how do I declare apps, for example? How do I declare dev shells, right? Things like that.
Okay.
Yeah.
Got
And then
it.
you'll see that it's also in per system as well, right? And so the idea is that flake is the raw output of the flake, whereas per system includes the structuring and the injection that I'm about to show you.
We got to make flake.
Yep.
We inherited our higher level inputs.
Yep.
And now we're in our attribute set that we are returning from this make flake.
Imports we don't really need at the moment That
Okay.
would be if we had modules that we just wanted to drop in and immediately get support for, right? We don't have anything at the moment. Overlays as well, overlays, things like that. Those can go into modules too. But you can actually just delete that whole block.
Okay. So just
Yeah.
delete imports for now.
Yeah. Nice.
Yeah.
Okay.
I'm
So
really
for
good at
me, this is the starting point of a flake, really, right? Like if
Uh-huh.
you were to be like, what's the equivalent of like the Docker file first line, right? This is it for me. It's the systems,
Okay.
the
Right.
systems array.
Yeah.
This will be what this flake supports, what systems it can build for. And because of the wiring that happens in per system, and you can see there's a lot more attributes below your cursor now, it will target each system for the one that you're trying to build for.
Right.
So there's a fun little part about Nix, which is it really just identifies your host system and builds for it. So with Nix, if you want to do like cross architecture support, it gets really weird and it gets really weird. Yeah. That's the best way to put it. And so normally it's easier. Yeah, it normally it's just easier to build on the system that it's on. And so this is how you support that. So if you're on an x86 64 Linux machine, it will target all the packages for that. If you're on an ARM 64 Linux machine, it'll target the packages for that. If you do not include something like you just did for a moment there, it won't work on that system, right? So it'll just say like, I don't know what system you're talking about. I don't support this architecture.
Yeah.
It is actually very difficult to support a lot of stuff on Mac with Nix.
Yeah.
There's a bit of a area of contention when it comes to the Nix community and Darwin upgrades because, it's very hard to support. And like, for example, Ghosties, going back to Ghosty, it doesn't support ARM 64 in the sense that it can build for it, but the Nix build setup isn't supported like to have a whole build by the time it was done. So it effectively means the flake doesn't support it, even though the binary does. So yeah, that's just like a little something to be aware of. Is it's kind of a toggle switch as well. You can say, all right, we don't support this anymore, just turn it off.
So you can turn that off, and then I imagine, with my great intuition here, that system here just might be that system argument that these systems that we have defined up here.
Yep. And again, this is one of the things that I like about Flake parts is that they kind of think about, all right, well, what are you going to need at the top level? And a lot of that is here, right? You've got the config self, which is the flake itself, really. But one of the things to note is that self and inputs has the first whatever dash or not dash. What is it called? What is it?
We in Haskell we call it prime, but I don't know if that's actually like something we would do other places. We would call that self prime.
First single
that's
quote.
okay. We can call it that.
Yeah, the first single quote for each self and inputs. What that means is it's targeted for the system already. So you don't have to do inputs packages dot legacy packages dot system. It'll have the system already targeted for you, and the same thing for self. So it makes targeting inputs even a bit easier because you don't have to resolve that. Okay, cool. So,
and inputs there is again just like basically whatever we put into the actual inputs to make flake.
Yep.
Okay.
And again, the only caveat, so you can use both technically. Like if you wanted to, you could use inputs without the singular quote, and with the singular quote together.
Okay.
It just depends on if you want it to auto resolve those packages for you or not, and which one you pass down, honestly. Cool. So there's a bit of comments here. It just says, as we mentioned, like per attribute systems can be defined here. The self inputs modules parameters provide easy access to attributes of the same module or same system, like mentioned. So we can delete all of this if we want. And it kind of says there, on the next quote, it says, equivalent to inputs, Nix packages, legacy packages dot hello. And that would mean that if we needed to reference this build somewhere else, that's how we would reference it. Right? And that's how you start making your like derivation dependency tree, where you say like, okay, I need inputs, Nix packages, legacy packages, hello, and then I need to build something else, and I need to build something else, and then it can, wire all of that up and figure out which ones it needs to build first. Do you think, pop quiz, do you think that packages.default builds our code? Or like what is packages.hello? Like what is that? Do you guys know?
Oh dear Lord. What is packages.hello? It's really literal. Packages.hello. Is it?
Yep.
Yeah. I don't know. I'm drawing a blank. Dylan's turn.
I have no idea. Like, is this Flake itself called hello? Or creating a package called hello? I don't know.
So it's actually just referencing the hello world binary in Nix packages.
Okay.
It's literally just like if you wanted to have the hello world package in your home environment, you could do packages.hello, and then you would be able to run hello world in your binary. So what they're doing here is they're saying, I don't have anything to build for you, so I'm just going to inject something as an output so that the flake works.
Okay.
Right. But this also does go to show you the kind of like reusability that Nix kind of has, right? Like this is a completely other binary, and technically like out of the box, if you were to say, I just want a flake that exposes like other specific binaries for me or something like that, you could just do that, and then have this track like a specific set of change sets and kind of separate it from Nix packages if you wanted or so forth. So one last thing to note here is the flake portion underneath it. This is the part where I mentioned before where say you needed to access the flake or set something as the flake outside of the make flake function, right? Like say you wanted to avoid that call and make sure that something's put at the top level, because right now your whole config's being wrapped, right? But again, you can make a flake without the need of make flake, right? So somewhere make flake is taking all of the inputs and attributes from Flake's main schema and then passing that in to this set here. So if you want to pass something backwards, you would put it in the flake setting or flake attribute set here. And this just means that you can go back to avoiding using make flake and just set something at the high level. Right now, we don't need any of this. Okay. But a good example here would be if you wanted to do NixOS or Darwin configurations, you'd have to put it in there. You couldn't put it in per system.
Okay. How would those, so just so my brain maybe gets this, no guarantees, but so we output that configuration for say Darwin, and do you mean like configuration in order to like run this package maybe, or like what do you mean by those Darwin configurations that we would put in here?
Right. So there are specific and this is why I think people in the Nix community get frustrated with these wrappers like flake parts or flake utils. Yeah. They abstract away the initial configuration that a flake exposes. Right. So as I said before, you can make a flake without the need of any of this and just start building what you need. However, you're going to find yourself into situations where you have to like target the system and like write a bunch of boilerplate code to get yourself there. Make flake bridges that for us, where by the time you go to per system, you have everything you need and you can just start making your packages, your dev shells, and your whatever, right? However, there are specific things in Flakes that do not exist in the per system category. And that is NixOS configurations, right? And Darwin configurations and the formatter, for example, right? Yeah. Those would not go in the per system block. And so if you want to be able to kind of think of it as like with a it's almost kind of like with Node.js, how you have a package.json and you can declare like other settings at the global level for something. Yeah. It's kind of the same thing here, where this flake setting gives you the ability to go back and set other settings at a global level that's not wrapped around the per system paradigm.
Yeah.
Okay, cool. So if we wanted to, you could just save this really quickly.
Yeah.
And close it. And then let's do a command to see if everything's working okay. So we're going to do nix flake check.
Is that this kind of
spaces?
Flake?
Sorry, nix space flake space check. Yeah.
Check. Okay.
Yeah. Now what's going to happen underneath the hood is you haven't created a flake.lock file yet. And this is something to note with whatever you work with Nix. If you haven't created a flake.nix file yet, and you go to run Nix for the first time, it's going to generate you a lock file at that given moment. Meaning that's where your packages stop changing. That's where anything else stops changing. And you're going to need to be aware you need to run Nix Flake update and all of that other stuff. But yeah, what it's doing right now is it's basically resolving that lock file. And then it's going to check the flake. It's just going to evaluate it, evaluate the inputs, evaluate the outputs. It won't do a build. So it does not, Nix Flake check won't necessarily say that your build works. Mm-hmm. And that's why Dylan, and I think Meta, you've even dealt with this too, where you can check and then you go to build and it does something a bit different. That's because the check technically only goes as far as it can without changing the system. And so if there's like sim linking that needs to be done to change something or other things like that, it just won't do it. Again, this isn't just your system, and anyone on Darwin probably experiences this at least like once a day where Nix packages just freezes. I don't know why it does this. I wish I did. I've seen documentation on something about like the daemon process hanging or something, but I have no idea. So
one eternity later.
I'm gonna get a refill. Maybe this will finish by the time I'm done, or maybe I should try again.
So the problem,
it finally finished.
Yeah,
okay,
there it
goes.
And this is why I'll tell you not to cancel this. Nix uses locks for everything.
Yeah.
So it's kind of like Terraform, where if you stop it in the middle of it, it's just like you just stopped me and I was doing something.
Yeah.
You know.
Right.
And it'll be like warning, store is locked, like you can't do anything until it fixes
you're
itself.
Completely
basically.
effed.
Yeah. So cancel with caution. And here's the trick I have learned: if you're gonna cancel, do it sooner than later. If you do it later, then you've definitely already created locks and it's already like gone.
A few moments later.
Welcome back, buddy.
Let's see. 6 minutes, 27 seconds. That's pretty good.
Yeah. Try running that one more time for me really quickly. just for funsies. I'm kind of curious. Yeah, see how much faster that is?
5 seconds.
Second time.
Cache is so good.
Cache is great.
Yeah,
so you can rely on cache
HDD. Antonio, it's so rude. It's so rude. It's a 2019 MacBook. I don't know what to tell you.
It's like it's still quiet. Dang, come on, man. Yeah, give him a little slack. Like, if it's not under a second, my man's like, I'm not not worth it.
I know.
So
users be like. All right.
So that's the first command that you'll start using with Flakes, basically, is checking them.
Check. Okay, we check them first.
Yep, and that really will help. Like, that's kind of like your lint. So, for example, if you were to take a step back and be like, hey, BG, what would be some of the things that you run in CI with Nix, right? Nix Flake check would be one of them. If you run Nix Flake check and you know you've got like a 30-minute build and you run Nix Flake check first and that fails, then that will potentially save you a 30-minute build time failure just because you were able to check, a specific thing. So Nix Flake check
is a lot more important than like the Darwin rebuild check versus the Darwin rebuild switch? Like, as far as like, it seems to save you a lot more time than, am I wrong about that? Or is it just that we're just building much smaller things? So it doesn't matter. Or in this case, we're building larger things, right? With the programs. Or maybe what I'm
Yes.
saying makes no sense. You're allowed
No.
to say, no, Meta, you're completely wrong. So yeah.
No. I think the difference between check on Nick's or on Darwin check versus this check is that one will build as much as it possibly can, whereas this one really just evaluates the inputs and to make sure that the whole thing is parsable, right? And can actually run.
Yeah.
It really will not build anything else. So yeah, so Nick's flake check again is the way to check for changes and errors and anything like that in evaluation. The next command I think we would do is Nick's flake show. If you are a Nix user and you want to know what a flake provides,
Yeah.
Nix flake show is a way to do that. Now, one thing to note about any of these commands, Nix flake show, Nix flake check, Nix flake build, like whatever, they reference what you tell them to reference. So they kind of work a little bit like Docker in the sense that if you don't give it a path, it's going to check your local directory. It's going to say, okay, is there a flake in my local directory? However, if you did Nix flake show GitHub, create melange app, then it would go out, look for the flake, right? Exactly. Yeah. What they just said in chat. You could essentially look at the flake outputs from another system. And this is what makes portability very popular in Nix. Because if you not only can you show stuff like that, but you can build stuff like that too. So yeah, let's go ahead and go back to the flake.
Okay.
Now, what's interesting is I'm going to show you how to set this flake up kind of from the mental process.
Sure.
But I think what happens is a lot of people start building with flakes kind of in the wrong approach, where they go like, oh, I want my dev shell environment. I want to be able to build my package and everything. And so they immediately go to building their package. But I kind of want to show you guys how this solves problems, and then I'll show you how you can like change it to your needs, right? Rather than just jumping in and saying like, I want to build OCaml with Nix, because it's not just that in a flake file. What we're going to actually start with is we're going to start with dev shells, right? Now, dev shells are hands down one of the most powerful parts of Nix, because as a developer, you have to quite often manage multiple dev shells, right? Multiple dev environments, configurations, stuff like that, whatever. So what we want to do is we want to set up a dev shell for this project. And we want the expectation to be that when you enter this dev shell, you get all of these things with it, right?
Okay.
So what we're going to do is we're going to just delete this line. Just go ahead and delete it entirely. We don't need it.
Okay.
And then we're going to say in camel case, lower Pascal case, I think is what it is. Yeah. So lower Pascal. Yeah. So it'd be dev and then uppercase shells.
Okay.
And then equals, and then let's make an attribute set with this. So yeah.
Okay.
Yeah.
And I guess I'm gonna need this.
Yep.
Before I forget. All right.
So dev shells, which is what we just added, programs, which is what we just deleted, and then one we haven't seen yet called apps are really the three main components of the per system part. Those are really the only three things you're going to work with. There's not much, I think, at least for most people, that you would end up dealing with in per system besides your dev shells, your apps, and your programs. Or your packages, sorry, your packages, not your programs. Why that's the case is because that's where all of the system level and cross system support is for. And that's why, again, if we take a step back to where you have the Flake and like Nix OS and Darwin OS configurations, those aren't, again, per system. Those are for specific systems. They don't have the ability to do like per system like this.
Yeah.
So because we have the ability to do this here, we can use a special key in this attribute set called default.
Okay.
And you can, default. And default is essentially going to be the dot equivalent. So if you were to do like nix build dot, that means that default becomes the system of that you're on, right?
Right.
Any other thing you put in, dev shells, packages, or apps that is not default will show up as its own thing in Nix Flake show, right? So
Which
default
goes back
is,
to like the default that we saw in the show, right?
Yep.
Like this
exactly.
default right here.
Exactly. Yeah. So that would be the default package that this repo exports.
Right. And then there's these other packages, for instance, in Melange that they're exporting Melange and Melange Playground for each one of these.
Yep.
Is that fair? Okay.
Yep. Exactly. Yep. Exactly. So what we're going to do is we're going to create a shell now that we can at least start working with. So we're going to do packages, pkgs, dot, lowercase mk, and then capital S, shell, basically, make shell.
Okay.
And then we're going to pass it an attribute set as well.
Okay. So we're going to go here and here.
So technically, I don't think you would actually need to add anything else to this if you were just like, I just want a shell, right?
Okay.
There are some things that you don't need to add any configurations to whatsoever, and you can get an output. Some things require configuration. In this case, though, however, we want to at least kind of make sure that our dev shell is working and that we have something being properly
So we need
passed.
something to see that we actually have something.
Exactly, yeah. So we're going to define build inputs as a attribute.
Okay.
So, yeah,
Like
build
this guy?
inputs. Yep. And then this will be an array. And then we kind of need to ask ourselves, what are the binaries that we need for this project? Like, what are the applications that we need? We talked about OCaml, right? We talked about Node. So if you wanted to, you could put OCaml in there to start.
Okay.
And you could put in Node as well. So it'd be packages. So OCaml is a little bit difficult. Dylan, does this need the latest version?
We are on 5.1.0 for OCaml, so it's not the LTS. Nice.
Okay.
And then you can do the same thing with
All right, there's
no need for a dash. Yep.
Right.
Node.js.
Node.js like this.
Yep.
Okay.
And then let's go ahead and just save and close this this file. The next thing we want to do is we want to actually try going into our shell.
Okay.
Right. So everything related to Flakes is normally under the nix command. Now, not all of them under the flake command. Some of them are just directly like nix build, right? So if you wanted to go into the shell, you could do nix develop, which is the second row, top one. And if you hit enter, what's going to happen is it's going to see that you have a dev shell x86-64 Darwin default. Right, that's what it's evaluating right now.
Beautiful.
And then it's going to make you a shell. It's going to go out. It's going to patch OpenSSL. Like it's doing everything it needs to create its own entire shell and any dependencies that sit in that shell. Now, if that happens, you can just run nix develop again.
Okay.
But yeah, after this resolves, then you will have essentially all of the packages you need for that shell, as well as you being put into that shell.
A few moments later.
So we ran nix develop. Now there's a few things to note about nix develop. The first one to note is that your prompt changed, right?
Yeah.
The reason for that is because you are absolutely in a completely enclosed Nix shell now, right?
Nice.
All of the symlinks and everything, the paths, everything is set up.
Awesome.
Yeah, and we are now sitting in Bash, and you can still run like some specific commands, but others might not necessarily work yet, right?
Okay.
Yeah. So for example, that would work because
This is OPAM is here.
Yeah,
Okay.
but that's because you've already got these on your system, I would imagine, correct?
Well, they should be. I don't know. Okay, this is your OPAM installation messing with your Nix shell. Yeah, so this is coming from my system, is what you're saying.
Yeah.
Okay.
Now, this is probably kind of a good time to just go ahead and say, the first elephant in the room here, which is if you already have a package manager, if you already have a build system, right? If you already have something that opinionates how things are symlinked or added to your shell, it could conflict with Nix.
Yeah.
Right? Because
Fair.
Nix wants to override those things, and if you got two things overriding them, like they won't work, right?
Yeah.
So going again back to kind of the earlier part of the conversation today, where I said you start seeing some things disappear. I think one of the things that kind of disappears here is OPAM.
Right.
At least from my own experience and what I've worked with Nix. It can provide you any specific version of the tools and the things that you need with it. So one of the things that might be helpful here is to basically say like, okay, I'm not going to have OPAM be something that's globally anymore. I'm going to remove that. And then I'm going to make it so every flake provides the specific version of OCaml with Dune, with UTOP, with whatever else. And then you're good. You don't, there's no more need for, and the nice thing about that too is now you haven't, and like, this is something that I think, like, again, developer experience is my passion. Like, it's something I'm massively, trying to find new ways to improve. And, one of the things I noticed is like, you're not, in this scenario, you're not opinionating the version to the version on your system.
Yeah.
Right. And a lot of developers don't even realize that they're doing that. Right. Where they're like, oh, I'm just going to start building something from scratch. Okay, cool. Well, what's the latest version? Okay, it's this node. All right, cool. That's now what it's established with,
Right.
But if you're, talking about tons of teams and building tons of different services and they all need to be supported under a specific version, you can have locks in place that say like, no, like you can have your own global version. That's fine. But the moment you go into my Flake, you should be using my versions and everything else.
Okay, so we just decided to go ahead and run a little sudo mv opam to opam.back, basically, to where I'm opam is no longer found in my system here.
Okay, nice.
All right.
That works.
We tricked it. Okay. So then maybe I should just do this again. Well, I guess this will, let's see what happens. Okay. This makes sense. Right.
So go ahead and exit.
All right.
Just type in exit. Yep. Now that's the next thing I want to show you, which is when you use Nix develop, you will go into, and if you want to leave a shell, you can exit it.
Right.
But you will always have that kind of like jump into, and as Antonio said in chat, if you use the environment variable in Nix shell, it should tell you if you're in a Nix shell, basically, or not.
Right.
Now see if you have OPAM. You do not. Perfect. Awesome.
No OPAM.
No OPAM. Cool. You probably don't have. You probably do have Dune though, right?
I do.
We basically need to uninstall all of your.
Okay.
Yeah.
Love it. Okay. So we have a new shell, and now Dune doesn't exist.
Nice.
Beautiful.
Awesome. Okay, cool.
So let's go back into tmux. Go back into the project we actually care about.
Yep.
And then we should be able to do Nix develop.
Yep.
Okay.
And
now if we say Dune
like,
or OPAM, we're clear.
Yep. But you should have OCaml.
That I do. OCaml version 5.1.1 to be exact.
Cool. So the shell is working as we expect now, which is it's adding the things that we want, and when we exit the shell, it's removing the things. A couple of small little pro tips here. The first one, if you want to keep your shell, which is actually something that bothered the hell out of me, I hated that this would go down to a bash shell where I was like, oh man, I want all of my profile. Like, please don't do that.
Yeah.
This is because Nix tries to be as pure as possible, and you're gonna hear this a lot in Nix, like purity, purity, purity. As Antonio mentioned, you can override purity basically, and you can tell it like, hey, I want to either eliminate things or add things. What you can do, yeah, it is. If you wanted, is instead of just doing Nix develop, if you go back and just put that in and then put space after that, dash lowercase c, and then space, and then as an environment variable shell, like just the word shell, right? And then you hit enter. Yeah. And if you exit, right, then you'll go back to the old shell. This is really where knowing which shell you're in can be helpful.
Got it. Yeah.
Because at that point, you're just like, I have no idea which shell I'm in.
Yeah.
But that's how I normally would go into a shell. However, there is one other thing. There's one other thing that we can do. Do you happen to have Nix direnv enabled on
I don't. I do not. I've never used direnv.
Okay.
The secret comes out.
You're about
Really
to.
easy to set up with Nix.
No, yeah, it's actually on my list. I was literally reading it, like the.
Oh, we're gonna do it right
little
now.
Thing.
You don't have a choice, Meta.
Yeah, we're doing this right now.
This is just like NeoVim, guys. WTF? All right.
I'm just showing you how you can do this. If you want to remove it later, totally can. No big deal.
Kidding. I actually wanted. I wanted it anyway.
Nice. So
and we're going to do a little direnv here.
Yeah, actually, I believe it literally is just direnv.enable. Just for clarity though, for anyone who doesn't know what we're talking about, say you're a developer and you don't like having to type nix develop -c shell every single time you go into your directory, or saying like, oh, I don't know if I have my binaries or whatever, right? Say you do just want that self-execution of like, I go in the directory, I get my binaries, right? Nix direnv provides that for you. It's the same concept of normal direnv, which is if you tell direnv to use the Nix flake, then it will actually do Nix develop for you and launch you into that shell automatically once you enter the directory. And once you leave the directory, it will unload it. It does create some extra nice caching. However, it does technically mean that you need to be aware that direnv is going to create a directory in your root directory. It is .direnv, kind of like how you get like .git or like, you know, things like that. This directory can be ignored, right? But it is something that helps cache your your dev environment effectively. And so yeah, we enable direnv in Home Manager using direnv enable, and then nix direnv enable to enable the support for nix direnv.
Okay, so I'm good with these two options here.
Yep, I believe so.
Okay.
Yep, and so you should be able to just save this file and then do a check and switch, or just a switch if you want. Totally up to you.
Okay, so we're here again, and I forgot what we did. We should actually have direnv. We do. Okay.
Yep. So you enable
Very
direnv.
nice. So let's just go into a little tmux and get back into create melange app.
Yep.
And where we go from here.
Okay, so now what we're going to do is we're going to add one more file to our project called a .mvrc file.
Right.
And this .mvrc file is going to tell Nix to really run, essentially. So in that file,
So is
let's
this
edit
normal?
let's edit that. Well, let's edit that file really quickly.
Oh, maybe it already exists.
Nope, it's just empty. So direnv noticed.
It will not let me touch it, basically. So instead, I'll just do this.
Yep.
Okay.
And then in this, just put use space flake. lowercase. Yeah, that's it. That's all you need. That will tell direnv to use the flake for your environment. So now if you do direnv allow, like it says, now it's going to read the env-rc. It's going
I'm
to
already in my
export.
shell.
Yep, it's going to create you a new shell, and it'll do a shell for you the way that you expect it, which is it'll give you the shell that you know, with your normal prompt, right?
Yeah.
So what's nice is just go up one directory for me. So, okay, so we've kind of messed around a bit with the flake enough now to kind of realize, like, okay, like, we know that we can make shells. We know that we can add binaries to shells, right? And we know that those are specific versions, whatever, right? Now we're kind of at the point where it's like we could add the things that we need, right? Add opam, or not opam, but add utop, you know, add whatever
Yeah,
else,
utop's
right?
a good example because, like, I personally love working in REPLs, and, like, I don't like having you know, that's one of the things I would imagine adding to most of my dev shells is the REPL for, you know, depending on the language, but, like,
Yep.
you know. Anyway.
Absolutely. Yeah, absolutely. And so, yeah, in this case, like, you know, you can do that, and you can start developing, right? But you're going to get to a point now after this process where you're going to actually want to build your software, right? You're going to want to say, like, okay, like, I am now ready to build this thing and try and see if I can package it with Nix, right?
Yeah.
So to do that, we need to go back into the flake.
Dev shells. We
So
did
we have
dev
dev
shells.
shells. Yep, we have dev shells.
We have systems. Now we have
yep.
to actually build something.
Yep. We're now at the point where we've kind of added and like this right here, this is a very common, I think, way for people to get started with Nix, which is like just get it working, make more of your app, build, and then you get to a point where you're like, okay, now I want to build it with Nix. How do I achieve that? And I don't think that's a bad thing, you know. It'll still be the same OCaml version. It'll still be the same Node.js version. There's no difference in the version of OCaml, whether it be made by something else or made by the OCaml binary right there, because it'll always reference Nix packages, which is the same thing. There are two real ways to build with Nix. The first way is to use the native Nix packages or functions that exist inside of Nix packages, right? So go to the manual, find the specific language you're trying to build for, find the function to build for what you need, and then build it that way, right? There are also nerds who decided that they would make like the turbo repo equivalent of a builder, which is like, I'm going to support every language possible. And that's things like Dream to Nix or Cargo or other kind of like or Crane, sorry, for Rust. There's one called Crane, which is like about building to Rust packages. Yeah. OPAM to Nix is a good example as well. It's this idea where developers notice that like there's more tooling that could be made there to kind of improve the experience, but it's not required. And a lot of the times when you use something like OPAM to Nix or Node to Nix or whatever, it'll actually be really annoying depending on like how mature your project is versus how opinionated the thing is that's trying to build your software. So yeah, so we searched and we found two things, right? OCaml, Nix packages, user guide, and then Nix packages 2311 manual. This is normally what you'll find is one of the two. Now, the manual is generated with the latest version of Nix. So whatever the latest version is what you'll see that is, right? It'll be 24 whatever in a year. But that is the actual manual itself. Right.
Okay. And this is what you actually want to go into potentially. Yes.
Now, the one thing I will say is sometimes the manual is hard to read, as you might have noticed. So there are people who are kind enough to go out into the internet and try and summarize that for you, which is the potentially the link above the one that you just clicked. I don't know if that's the case. but I can
Okay,
show
so
you as a way to
we'll see.
understand if it is. And it does look like it is. Now, the reason why I know that this is because if we look at the code, you'll notice that it's referencing packages, right? It's not trying to use its own library or its own, system of like building it. It's just saying, hey, this is how you can package OCaml with Nix. If we look at this code from its core, we'll see that we have a parameter attribute set being passed, right, with a bunch of attributes in it. And then we have the next thing, which is build Dune package, right?
So this is the reference to that function that like Antonio mentioned earlier, right? This is the build Dune package function in Nix packages, essentially.
Exactly. And if there's any other Dune package that needs to be built, it uses the exact same function.
Okay.
This is one of the reasons why I say it's good to start with the Nix packages builders, because everything in Nix packages is built with these functions. Not everything in Nix packages is built with like OCaml to Nix,
Yeah.
So the support there is more challenging and things like that. In this case, you'll know this should work.
Okay, so we have build Dune package rec, p name, angstrom, version. Okay, this all seems. I'm guessing this is the project that they are building.
Yep.
And the version of the project they are building.
Yep.
And then we're specifying minimal OCaml version. I don't think I'm going to explain that one. And then we have source fetch from GitHub. Okay.
Now this is unique to
I'm thinking
Nix
about
packages.
those. Okay.
And the reason for that is because Nix packages itself as a repository just builds software. It doesn't store the source code to any of that software.
Right. So this is why I can do a Nix Flake show melange GitHub blah 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 command. Okay.
Yep, because it's been
because I'm
described.
specifying all that information right here in my Flake.
Exactly. Yep. So yeah, so this is again, we're starting to really get comfortable with like the language, the the reusable functionality of it and things like that. So yeah, so what we want to do is we really want to reproduce this in our Flake. Now the thing that becomes challenging about doing what we just did is then you go, oh, that's great. I just saw a file with like parameters already being passed to it. How do I get those parameters? Right? Like,
correct.
I'm going to show you. But the thing to note about Nix packages is they have a design opinion, which is every package should be have a pass parameter for that package and its dependencies. Right? So every single package in Nix or Nix packages at least, that has its own file with its own attributes and parameters like that means that those are the exact dependencies, the exact functions, the exact everything needed to build that piece of software. But they all come from Nix packages at the end of the day. It's just a bit of like magic that's used to glue it all together. An abstraction to make it easier to build 80,000 to 100,000 packages, right?
Right.
So what we're going to do is we're going to replicate that. And the first thing we need to do is outside of the dev shell's attribute set, we need to declare a new attribute set called packages.
Okay.
So yeah, so now what we have done is we have said, hey, we have dev shells with a default. Let's do the same thing, but for packages. So we need a default package, exactly. And we need to reference the build Dune package method or function in Nix packages. I'm going to tell it to you, which is it's packages dot OCaml, lowercase, and then capital P.
Oh, okay.
Packages.
Packages,
Yep.
right.
Dot build Dune, either
way they
package
have
or project. Yeah, one of the two.
Okay.
And then an attribute set passed into that, right? Because you're always going to pass an attribute set into the thing that you're trying to build. Now, if you were just like, if you just hit here and you were like, I don't know, man, guess what? You can do Nix Flake check and you can do Nix Flake show to see if you have wrote the right reference, right? So that's what I would do. As a matter of fact, go ahead and save it really quickly.
So we can do this, and then we can do Nix Flake check.
Well, so one thing to note about direnv is anytime you modify your flake, it will reevaluate your direnv. Yeah.
Okay.
So that's what it did. The first thing showed you the error, and then the second thing showed you your direnv reevaluation.
The direnv.
Yeah.
Changing.
Okay.
So.
But you nailed it. We did it right because it's saying that something is now being called without an argument of version.
Yeah.
So that means that we actually found the package, we executed the function,
right?
But we didn't provide that attribute set with version. So if you were to next say, hey, BG, I don't know what the F build Dune package takes as attributes.
That sounds like me. Yeah.
There you go. Now you know how to check and see what you're missing. So now you put in version, anything you want.
All right. So this is, version.
And then a string. Yep.
Okay.
Of whatever. So what version is... sure. And it can be anything. Nix doesn't care at all. Like this version is just a string. It can be whatever you want. Okay, so you've added version now.
Okay, so we could just build it and try to find out
pretty
what
much
happens next, right? Okay.
Yeah.
I can't remember if I wrote. Let's see.
P name.
Okay, so then we have P name.
Yep.
So we could kind of see here, up here, we have P name version native build inputs as an optional, I'm guessing, and enable parallel building optional with the default of true.
There you go. Yep.
So good at this. Okay, so we
you know what's
will...
funny is I actually think Meta's gonna love Nix. In like 2 months, he's just gonna be deep down the Kool-Aid. So I'm gonna help you with one more thing, just because we need it anyways. And it's the source. Right, so it doesn't say it in the list, but you will always need a source, to build something. So you're just going to do src equals. Now no string, so just dot / dot.
Is that a /?
That's a / dot. Okay, cool. So we've got p name, source, and version. So if we wanted to save this really quickly and then do a check, we could.
Okay. So far, every time you've said that, you've wanted me to do it. So I'm going to go ahead and do it.
I'm glad you're getting the rotation here. Yeah, that's good.
He's just, a quick learner.
Yeah.
Quick.
Oh, yeah. So good.
Hey, so there we go. We evaluated without any errors. Pretty good. Okay. So now if we want to actually check to see if stuff is building, we need to run the build command. The easiest way to do it is just nix build. That's it. Just nix space
Now,
build.
should I maybe delete our little target directory so that
No,
is
no
there...
need.
Okay.
Because everything's going to be done in the Nix store.
So I know it's going to be... We have a way of checking, yes, we just built this because it's in the store. That makes sense. Okay.
Yep.
So just nix build.
Yep.
Okay.
Now, I want to preface everything we do from here on out, which is I just showed you guys how to create a flake, how to investigate, how to, get a language set up as well as a dev shell set up.
Right.
At this point, whatever craziness that's in your application, that's going to be on you, okay? I have no idea what dependencies you have in here. I have no idea how your build system is written. I have no idea how it, where your entry point is, right? This is the equivalent to NeoVim configuration where it's like, sure, you might know NeoVim, but you have no idea what my plugins are, know? So yeah, you're really at at this point I kind of have to be like, I'm not responsible for whatever you do at this point. Yeah, but what I have provided you with, right, is the tools. Really, you're already there now. You're now building with Nix. You're building for a specific language. You're using the function the reusable function that Nix provides. It's in a Nix flake. It's a Nix derivation now, and it'll build the same way every time. Now, what I want to say about this is compare that to a Docker file. Think about everything you need to do in a Docker file that we just kind of got out of the box for free, right? You don't need to worry about a base operating system. You don't need to worry about dependency packages and the things that you require for your system or or the thing you're trying to build. Why? Because Nix knows about OCaml. It knows the dependencies that OCaml needs. It knows the same thing about whatever else that's a part of your build, right? And it's going to be able to resolve that. So with like 50 lines, you've now got a reproducible build. Not only that, but also a reproducible dev environment, right? And I'm going to show you the next part in that now. I'm going to show you a cool little pro tip that I do with all of my flakes. And this makes dependency injection seamless with Nix to where I don't even have to ask anymore, what are some of my dependencies, right? Nix has the ability to tell or to give you the option to say, hey, I want my shell to have everything that comes from my build environment. Think about how difficult that is to do. I want everything that's in my build environment in my shell with one line.
Yeah.
The way to do this is let's go ahead and remove build inputs that line entirely.
Here?
Mm-hmm.
Okay.
And what we're going to do now is we're going to say inputs from.
And this is on this line, right?
Yep.
I'm getting there. Inputs from.
Yep. And then equals and then an array. Inputs from is a special input for make shell, which will take derivations and then any inputs for those derivations, meaning command lines, meaning packages, whatever, will then get injected automatically into your shell for you.
Okay.
So what we're going to do is we're going to say inputs from self with the single quote because we want to reference the flake dot
you guys
packages.
Like your spaces around your things. Okay.
Yep. Self dot packages.
Like that kind of packages or the other kind?
Full packages. Because what
this
you're doing is you're
the
referencing
packages that I just created 3 down.
Exactly. Okay. Yep. Dot default.
Okay.
And save it. Let's save this file.
Okay.
And then close the file as well. Yeah. Let's do a quick reload. So do that's weird. It should have updated. Maybe it's because there's no changes. Do direnv space reload. Cool. So what you just did was you set up a shell now that takes all of the inputs from your build function and adds them to your environment. So you should have OCaml. Yep. So you've got OCaml now. And you don't remember, it's not, build inputs with an array anymore of everything. You just got OCaml because that's what the OCaml builder needs.
OCaml packages, build Dune packages needs OCaml.
Exactly. Yep.
Right.
Yep. Now, does that mean you get everything? Yeah, maybe not. Right. Like, for example, try utop. You might not get utop, but that's because you don't use utop to build. Yeah. So in that case,
not necessary, right? It's part of the developer. It's a developer tool, not a build tool.
Yep. So let me show you how to add this because you said you wanted it. So we'll show you.
Great.
So we've got inputs from. Then what you'll do is we had build inputs. Now, okay. Antonio argued before that it's native inputs, build inputs, it's build inputs. Like, to be completely honest with you, native inputs and build inputs are not very different at all. If it's a binary, it's still going to add that to the path and it's still going to be executable as a binary. Okay. Native inputs are normally what are required for when you're building something and you need them a part of that part of the build process, meaning that you need them natively to the build step. And it's not just like a normal build input, but this is something native to the system, essentially. So you can either do native build inputs or build inputs. It's up to you. I normally just do build inputs because it'll add it to my shell, and that's all I really care about.
Like,
so what we'll do is we'll add another attribute. Yep, we'll add another attribute called build inputs again.
Okay.
And then this time we'll do packages dot utop, I believe. I think, or it might be packages ocaml.
Okay, so we have packages.ocaml packages.utop because that's what it is showing in Nix packages. Makes sense.
Yep. And then if we save this and close it, we should have our shell automatically add utop because we're using direnv.
Yeah.
See how direnv immediately saw, and then it goes, okay, let me go get it. Now you should have utop once this finishes. This is actually kind of why I like direnv. Like, some people don't like it. I really do. Like, it's made my life so much easier. You know, I don't have to think about, am I in the shell? Am I not? Which binaries do I need? Which ones do I not? You know?
Right.
And every developer I've shown utop to at my work, or not utop, sorry. I've shown direnv to at my work. They've all just been like, yeah, this is awesome. Like, this is perfect. And I even have developers who don't know Nix, but we got them set up with Nix, and then we just said, like, run the command, and that's enough. Like, they're able to, because it's all Nix, like, it's fine. It'll just take care of it. So,
We're still back.
So again, at the very top, we have description. You can change that to be the metadata of really whatever this flake is and what it does, right?
Yeah.
Inputs.nix packages URL. You only have one input, right? Think about that. You haven't added anything else. You've been able to use all of the packages, all of the code and everything out of just Nix packages. That's how, and as somebody who's, you know, again, coming with their own language, their own setup, their like so much is supported out of the box here.
Yeah.
It's kind of crazy. We, you know, do our outputs by using flake parts. So we're using flake parts as a nice little templating for us. It allows us to set the systems that we want to support, right, in a nice little form factor that makes it easy for us to manage. We have per system. The per system block makes it so that when we want to describe things like dev shells and packages, we can have that multi-arc support, right? Dev shells gives us a multi-arc supported dev environment. And like, that's something to note here is like, we're not just talking about an environment that just works on your system.
Yeah.
This will work on Dylan's system. This will work on my system. Like, as long as the architecture is in systems, it's not just a dev environment that you made a bunch of shells out of. Sorry, bad cop, but it's not just a bunch of shell scripts. It's an actual reproducible environment that you can get every time. And so that make shell will guarantee that you get that, and every developer gets that, right? Same thing with packages. Packages will make sure that the default package uses the build dune package, which is like the, you know, supported function within all of Nix packages. You're using the same thing that, you know, tons of other things are being built with. You're using it with your code, right? And now, really now, and this is why I say, like, you know, it's kind of mileage may vary here. This is where you have to start asking yourself the question, what are my build dependencies in OCaml, right? And what do I have requirements here for that? There is one other thing we can do really quickly, which is we can talk briefly about the fact that this is a multi-language repository.
Yeah, that was my question.
Right? So this is not, like, we've done a lot of OCaml stuff, and that's super awesome.
Don't worry.
Right? But we haven't really supported Node at all, right? Now, one of the things to note is, do you have Node.js installed globally?
I probably do.
Okay, so this is like the common pattern, right, with Nix, and you know, you yourself were like, I want to know what this experience is. This is it.
Yeah.
Which is, if you have something global, you really start finding yourself tearing those things down and saying, like, okay, let me move it into, you know, and then what happens is, once you remove it globally, you'll start adding flakes everywhere. Right, every directory will have a flake for everything you need, and then you just jump in and out of directories, and you get the things that you need when you're in those directories. So I think Node.js is a little bit easier to work with than OCaml, just because OCaml and OPAM do like environment variable changes, whereas I believe with Node, it'll just override the path that you normally use. So let's try this just to see.
Sure.
Let's add Node.js to your build inputs.
Sure.
And then let's see where if that automatically goes to the store, then we're good.
And was it something like this?
Yep. And that becomes really like common, you know, really normal. To just be like, oh, I need a package. Just go add it to your build inputs. Okay, cool. Reload. Direnv reload.
Direnv. Oh, that's right. So I can probably just do this. So we're there. We could also try this, which also tells us, hey, this is the node from Nix. It's not the node from Brew, which would be in obviously a different place, right?
Yep.
So this looks pretty good.
Yep. So here's what we would do now. We would do, now that we have this concept of like build inputs and inputs from, right? We kind of know now, and this is where like, this is why I started you with dev shells.
Yeah.
Right? Because now once you get this set up, you really do start asking yourself, how can I do this by just going and having everything through inputs from?
Yeah.
Right? You really don't want to have to feel like you have to add more and be like, oh, what version and whatnot, right? So what we would do is we would do the same thing with default, but with our Node.js package that we want to build.
Let's see. I imagine it's called create melange app with dashes in this case, but we just have to find what it is here though, right? Like what
So
are
there's a couple things we have to do.
Okay.
In all honesty, the first thing we have to do is we have to make sure that we just have, you know, whatever basic framework set up to build the Node.js package, right?
So we don't do any building on the Node side with this. I was wrong earlier. There's no Vite or anything. It's just straight up ES modules.
So, okay. We're
So
kind of
do
in a
we
little bit
not
of an
even need to
interesting
build
situation.
anything? JS?
Yeah, so what happens, the flow here is that when we run Dune build runs Melange. Melange compiles all of our OCaml to JavaScript, and then we just publish that JavaScript to NPM.
So why do you have a package.json?
Because we bind to NPM packages from OCaml, if that makes sense. Like we can call JavaScript packages from OCaml.
So then I guess my question though is like we have to get those packages and install them from somewhere, right?
Yeah.
So like without something in our Nix in order to get those packages, like so our build step is just Dune, but we still have to get all of our JS dependencies from somewhere.
Yes.
Which aren't all going to be in OCaml packages.
Right.
So how do we do that?
So here's what I would do first is I would just try building currently, because it sounds like the process I'm hearing is that the function build Dune project is actually also going to run Node stuff under it. Is that correct?
No. There's
no
Node in the process. The only reason you would need to use Node is to run the app once it's compiled with.
Let's try building then. Yeah, let's try building.
Okay, so we should
We'll
just do
Nix
Nix build.
Yep.
Okay. I think this worked before I even added Node, but that could have been using my system node, I guess.
I'm confused how it would work without us declaring like our actual OCaml dependencies.
Well, so Nick's magic. There are some functions that if languages, for example, already provide lock files, right? Or package versions or things like that, Nix can inherit those. And it can say, okay, well, you've already got it. I don't have to worry about knowing where it is. Like, you'll notice that there's no Go packages in Nix. That's because everything's a repo. You know, everything's in gomod.sum or in GoSum.
So is this... I'm curious if it's using the Dune project or the OPAM file.
It's going to use the Dune project because it's building a Dune package. So it would use anything that you have as a dependency in your Dune package setting out the gate. Yeah.
Gotcha.
So like here, let's do this really quickly. Do an ls-alh for me. Like, let's just look in the directory. You should see a result. There it is, right there. Result. So let's see what's in there. What's in the result directory? There's a lib and a share. OCaml. So
Okay.
that means that we have the specific OCaml version that's needed. Okay. So what's happening here is that Nix is basically saying, hey, I'm building your project, but I'm not recognizing what you want me to build. Right? So I'm just
okay.
like building basically what I can. Right?
Yeah.
And this is what happens sometimes with these builders where it's like, sure, you want to build a Dune project, but you might need to figure out a little bit more of like what the build target is. Right? And this is what I said by like mileage varies a little bit here.
Yeah.
You know, if you're like maybe not using a standardized build target, or you have a different way of like, is this a binary application? Is it a library? Right? How is that defined in OCaml, or I'm sorry, in Dune? We could look at the manual, right? And then look and see, right? You'd basically just look and see. We just looked at a way of getting started with a language, getting the mentality of like moving your stuff, you know, into your local project Flake, you know, getting your dev shell set up, all that kind of stuff. And that's great, right? But sometimes, man, you just can't build it with the normal builders that exist. Nix provides a set of what are called trivial builders. And these trivial builders are literally there to, I mean, honestly, do exactly what Bad Cop does, which is write bash scripts. It's here to write bash scripts, but they're reproducible bash scripts because every input that's used in these are in the Nix store, right? So say, for example, you were like, I don't necessarily want to build this way. I just want the CLI so that I can run these commands myself and then take the output and do something with it.
Yeah.
That's what these trivial builders are there for. They're there to kind of be as the gap between like the really core language-based builders and then, oh, I need something that's abstract, or I need something that's different that I can't fit within the paradigm of these builders. And to give you an example of this, if you scroll down a little bit more, there should be one that says like, so you'll see like run command CC, which means it puts the C compiler in the environment for you. One called run command local. Now here's where they get really interesting, which is the write text file, write text script, like all these write text. This is literally writing shell scripts in Nix.
Neat.
But again, the benefit here is you're also injecting every binary, every requirement. So to give a quick example of how I solved something really cool with this the other day, I had a service that needed migrations ran, right? Now I build this service with Docker. I build this service with Docker, but I technically build the Docker image with Nix. So what I did was I realized that I needed Atlas, which is a migration software for Go, basically. But I need Atlas to run a very specific command, right? Like I needed to run like Atlas go migrate whatever, right? Well, if I wanted to, I could try and figure out a way of like passing those arguments to the Docker container when it starts in the pod and and whatnot, and just like have this headache, right?
Yeah.
Or I could just tell Nix to write me a shell script and then put that shell script in the Docker container with the binaries that it needs. And then boom, now I can just run the migrate command as an actual binary essentially, but it's really just a shell script with a wrapper. This is what we call wrapping in Nix. And it's the concept of I'm going to create a reproducible script that wraps the execution of what I'm trying to do. And that's exactly how in the Alt F4 stream nvim repo, I'm able to start neovim with all of the binaries that you need. Because technically what I do is I expose a shell script that starts neovim, but in that shell script, it has the path of every LSP in the store inside of it. So you never have to be worried about starting neovim without the LSPs, because I write a script that basically echoes all of those LSPs into a script. So when you run neovim in my Flake, you're running a shell script that then takes the arguments and then injects them into neovim. And this is, again, that concept of wrapping.
Yeah.
So you might find yourself in a scenario where you're saying, like, sure, I'm building with this language and I'm doing this and I'm doing that, but I'm doing something so different that I can't use the normal builder to do that. So I'm going to use something like these, like trivial builders, to accomplish that. So yeah, you know, we've gone through a lot today. You know, in all honesty, like I said, I think the reason why we walked through it the way we did today is I wanted you guys to see the common developer experience, which is really what we did. You know, you kind of go like, all right, I want to build something with Nix. Okay, how do I make a flake? You know, okay, what language do I use? Okay, how do I build my dev shell? Okay, how do I build my package? Okay, how do I keep maintaining that? One thing to note about Flakes that we didn't really talk about was that Flakes also provide the concept of apps, flake.apps, yeah. Or per system dot apps, one of the two, right? Per system is, huh?
Okay. No, I was just reading something.
Oh,
Okay.
yeah, all good. Essentially how apps work is Nix gives you, in the same way that you do like Nix build whatever, you can do Nix run whatever. And what it'll do is it will build the thing in your Flake and then run it, right? Now, does that mean it'll run it with like all the command args and everything? No, you'll notice in the default.program here, it just builds the package and then references the binary. But let's talk about that development experience really quickly, right? You do Nix develop to go into your shell and get all of your dependencies and try and, you know, maintain everything you need. So anyways, yeah. You use Nix develop to go into your shell, right? You use Nix build to build, and then you use Nix run if you want to actually build and run. Right. And Nix run works the same way like Nix Flake show or Nix Flake build or Nix build or whatever. You can either tell it to reference the thing locally, or, and this is what blew a lot of my coworkers' mind at work. At work, we have a Python application that is written in Django, right? And it is one of our core components of our system, and it has a ton of packages inside of it. It's just a mess. Yeah. And the easiest way to get that running locally was to clone the Docker container and then run it, right? Yeah. With Nix run, I can just say Nix run this repo, and it will evaluate the Flake, build it locally, and run it for me.
So yeah, I feel like it's kind of like here. I mean, this is what's provided for me anyway by the template. But I have like a basic concept of replacing some of the key things I've put in these different places. Really, just a few lines. That if I just had like a normal package that I'm building, like something that's probably a little bit more typical, I could do this for, you know, any language I can think of, right? You know, I mean, anything that I have a build function for Nix.
Exactly. Yeah, exactly. And this is what makes Nix, you know, very powerful, is once you see the potential there, it can build, and you can use the same file to build any language, have it be reproducible, have it to be described in the declarative way that you want, right? Yeah. And yeah, have it be portable as well. It really does, at the bare minimum, kind of rival Docker in a lot of ways, you know, from the developer experience, not from the, okay, now I want to run it on 1,000 servers. You can't do that with Nix. Like you can't. You can build it reproducibly every time though with Nix, and yeah.
So could you, like, I think I saw you going back and forth with Mitchell Hashimoto. I said that right?
Yeah, I think so. Yeah.
About
so.
like using Nix and Docker together. Would that look like you end up building your package, binary application, whatever, with Nix, and then building a Docker container around that?
So yeah, the way that I meant what I said in that tweet is that I think containers work really well with Nix, and Docker is a
Yeah.
container platform.
Yeah.
I think one of the things that I think to really like, dude, I'm never gonna just like give you one corner. I'm gonna give you all the angles I can. If you build something with Nix, like a Docker image specifically, it will be so lightweight that it will not even have the SSL certificates to make proper SSL requests because it can't authenticate the SSL certs because it doesn't know what the common, roots are. That's how lightweight it is, right? So I was really deliberate by saying the word Docker there because if you build a Docker image normally, then you get all of that out of the box. And so there's two ways of doing the Docker approach with Nix. The first way is like the purest, like just build and put that pure binary in there and call it a day, right? Another way is to do what you're talking about, which Mitchell does do, which is he actually describes a Docker file essentially with Nix, and then Docker still builds it. But it does what you're saying, which is like it builds the binary with Nix, and then it injects that into the Docker image itself. So it's still a super lightweight image, you know. But the difference with that is if you're like, well, no, I need to support, Alpine Linux or something, you'll never like if you ever build a Docker image with pure Nix, you'll never get an actual operating system with it. You'll get a scratch image with a binary in it. Right. But if you need those lower level kernel level support or things like that, then you're going to need to still build with Docker.
Gotcha.
But like my developer experience right now for everything I do is a combination of Docker and Nix. So Quark, the thing I'm building on stream, is a distributed content creator tools platform. It has a database service, it has a cache service, it has an IRC service, it has a API service, right? Just like tons of services, right? Like how do you run all that shit locally and make it make sense? First off, what I did is I made everything run through Nix. So everything Nix run dot. All my repos, whenever I want to start my program, I just do Nix run, right? Now, I decided to use Doppler as a way of injecting secrets into my run binary. So what I do is I say Doppler run, and then I say Nix run. And that will run Doppler, update my shell, inject my secrets into my binary, and then run my binary locally, all in one. So we've solved for portable secrets, portable commands, and everything else. So that's kind of my approach and then anything else I run in Docker. And I use just as a way to start the environment. So if I say just up, it's the equivalent of like make up, right? Make will run anything I want it to. In this case, it runs Docker underneath the hood, and then it starts my containers for me. What makes that really nice? Nix has also no opinion whatsoever around the containerization part. Like Kelsey said in the tweet, Docker provides like its own encapsulated file system and like its own network interface, even emulate and stuff like that, right? Nix is literally just a shell. You don't like if you're like, oh, I want to run a Postgres service with Nix. Well, guess what? You're about to create a Postgres directory somewhere in your home directory because that's what it's going to do, So I think to go a roundabout, way of answering your question, I do think that they work really well together. I think that you're going to find yourself running Docker Compose with Nix locally, and then you're going to build an image, and then you're going to deploy that to the cloud, as an image. Well, as always, feel free to hit me up in the Discord. We do have our little Nix corner in there. So, if you need help, let us know. Like, I'm definitely down. But yeah, I like I said, I think if you find yourself in a scenario where the original builder's not working, going to the trivial builders and just saying like, I'm just gonna figure this out is totally fine.
Cool. Everyone who's been watching, thank you for tuning in. Everyone that's followed and subscribed, I super appreciate you. Make sure y'all give Meta and BG follows and check out their streams and YouTube content because it's top notch. And yeah, super appreciate everyone.